Okay, bachcho, yes. So when starting with stability constant, can you tell me what is a ligand exchange reaction? Yes, ligand exchange reaction is the one in which one ligand is replaced by another ligand. But does all of this happen at once, or would it happen step by step? 6 ligand एक साथ चलेगा एक साथ अगर does this, is this what happens? Then what would have happened? Yes, पहले one of the ligand substitutes and the other one substitutes and so on and so on. ऐसा ही होता है नहीं होता? When this is happening, what is basically happening? Example लेते हैं. Let's take the example, very basic example of copper. क्योंकि वो we often do that example. Okay, बच्चों. So what happens when I add ammonia in excess to a copper solution? What happens? Yes, बच्चों. क्या होता है भाई?
Ammonia replaces some of the.
Yes, बच्चे, you were saying something. Can you see the screen now? हाँ बच्चों. Yes, बच्चों. Yes, Isha, you were saying something. What happens? Hmm?
Well, I was saying that the ammonia would replace 4 of the water molecules.
But all of that will happen at once, or will it happen step by step?
Step by step.
Bilkul, that happens step by step. So we can make equations where we say that this complex, इसको ऐसे लिखते हैं, copper H2O and plus NH3 it gives me copper NH3, one of the NH3 replaces and 5 H2O remain with plus charge and H2O. Is this right? There is an equilibrium that one ligand replaces the other one after the other, and this happens. फिर अगर मैं दूसरा वाला बनाऊं, if you can tell me कि ये आ जाता है मेरे पास. Observe what is happening, and then the second ammonia replaces, and we are left 4 water ligands, and then another ammonia replaces the water, making 3 ammonia and 3 water, and eventually another ammonia replaces, and we get 4 ammonia. We are left with 4 ammonia and 2 water. Is that right? If you combine all these 4 equations, you'd be left with the final equation or the overall equation, which is 4 ammonia replaces 4 water. Is that right? This is the overall equation. Right, bachon? So do you understand every step of the ligand exchange?
Yes, sir.
If I ask you to make an equilibrium constant for this one, a Kc for the very first one, how will you do that? तो मैं K1 कहूँगा फिर eventually. But if I ask you to make Kc for the first one, what would that be? Very good. It's in the numerator now. And और कौन सी प्रोडक्ट है? And so this is just the equilibrium constant for the first step of the ligand exchange. Is that right? दो लॉन्ग ब्रैकेट्स हम जनरली नहीं लगाते, बट कोई मसले की बात नहीं. I'll just explain everything पर उसके बाद से. Okay, so this is the Kc for the very first one. But again, water की concentration is almost the same. Water की concentration is a constant वो equilibrium के साथ. It does not change often. Instead of considering water again and again and again, हम water की concentration को उधर ले जाकर what can we do? यहाँ water की concentration क्या हो रही है बच्चों? Multiply. We just divide the concentration of water on the other side. And we are left with another constant जिसको हम K1 कह देते हैं फिलहाल. तो long brackets नहीं लिखते, don't worry. This is what we are left with, and this is called an equilibrium constant for the first step of the ligand exchange. Then you can find the one for the next step as well. The next step ka and फिर next step ka. So how do you find the overall equilibrium constant provided that I give you equilibrium constant for each individual step? सोचो overall क्या होना चाहिए था? सबसे पहले तो ये बात बताऊंगी. Yes, बच्चों.
सर ओवरऑल में उनके नंबर ऑफ मोल्स को ऐड कर देंगे.
9. If this is the first equilibrium constant and this again is इसको कहते हैं individual stability constant ही है. Here we call this stability constant. लेकिन individual होता है ये. So individual, what is it showing me? That the greater the value of K1, the more stable this ligand is. Can we agree on this or not? The greater the value of K1, the more stable this particular ligand is. लेकिन उसके बाद K2 की वैल्यू आ जाती है हमारे पास. If I were to find K2, what will that be? Product.
सर तो ये जो आपने रिएक्शन सारे लिखे हैं उसमें सबसे ज्यादा स्टेबल कौन सा है?
जो हमें eventually मिलता है.
एंड पे.
बिल्कुल, because that is the one we eventually get. Isn't it the most stable one, बच्चे?
यस.
My question is still the same. How do I get the overall stability constant provided the fact that I give you all these individual stability constants? I give you K1, I give you K2, I give you K3, I give you K4. How do I get overall stability
Sir,
constant?
um,
Overall होगा क्या
maybe
है?
we add,
सोचो. Yes.
maybe we add them.
Okay, think about it. I've given you a couple of ratios. जरा गौर से इस बारे में सोचना. And then tell me, if I ask you overall K stab stability constant, what will overall K stab be? What will I get in the numerator? Is that right? And what do I get in the denominator? Now think about the individual constants that you have. और NH3 की पावर क्या हो जाएगी? How do you get this from individual ones? How do you get the overall stability constant? Yes, बच्चों. Think about the ratios. I need NH3 की power 4 आ रही. That means NH3 into NH3 into NH3 into NH3. Each stability constant has just one NH3 in the denominator. How do I get the overall stability constant?
We added a power.
9. To multiply individual stability constants. So if you want this K stab, the overall stability constant, what did you have to do? You had to take K1, you had to multiply it by K2, then you multiplied it by K3, and then you multiplied it by K4. So overall stability constant can be obtained by multiplying the individual stability constants. You can see that from the ratio as well. Is this clear?
Yes, sir.
Yes, sir.
Yeah. So the larger the value of the stability constant,
The more stable.
the more stable the complex being formed after the ligand exchange. Is this clear or not? Can we agree on this? Is this clear, class?
Yes, sir.
Sir, stability constant की definition क्या होती है?
It is just an equilibrium constant that involves complex when a ligand exchange is taking place.
Okay.
Now let's have a look at a past paper question. Similar है, बहुत generic सा question है. Transition metal often exist as hexa aqua copper complexes in aqueous solutions, which involve ligand exchange are reversible. So yeah, I told you when even I was teaching you reversible reactions के वहाँ पे ligand exchange almost सारे ligand exchange reversible होते हैं, but specifically the chloride ones you studied as the reversible one. But right now अब तो ये वाले को भी reversible ही कहेगा. Write an expression for the stability constant for this equation. Give its units. Yes, class. Can you do that? अभी किया हमने units नहीं बताया. यूनिट्स तुम लोग मुझे बता सकते हो क्या होगा इसका एक्सप्रेशन? K stab will be equal to what? अलग से ट्रांजिशन का I've told you people ब्रैकेट नहीं बनाते कॉम्प्लेक्स का Cu H2O plus 2 and NH3 is taken 4 times. What are the units? Can anyone tell me the units?
Sir, mole -1 dm minus
पहले आराम से concentrations देख लो. Mole
-1 dm -3.
mole कैसे -1 है?
Sir, एक से कैंसिल हो जाएगा ना.
Very good. Mole yes, mole is -4 and dm is
-1.
12. इसकी concentration mole per dm cube ये तो cancel हो गए. We are left with concentration to the power 4 लेकिन denominator में है वो. सही है. So that is mole -4 and dm 12. Is this clear? Okay, the numerical value for K step for this equilibrium at 298 Kelvin is 1.20 exponent 13. Explain how this value relates to the relative stabilities of the two complexes. First of all, tell me, is this a very high value or a very low value?
High value.
Very high value. So what does that mean? That the complex formed in this particular equilibrium is a very stable one. एक दफा once we make this complex, वापस दोबारा वाला complex बनाना is not easy. Understanding this, हम लोग तो पढ़ते हैं ना equilibrium में ही नहीं. But the main reason is once this complex is formed, it is a very stable one, complex that is being formed. Is this clear?
Yes, sir.
Okay, let's have a look at another question.
सर आप इसको नरेट कराएंगे इसका आंसर.
Okay, बिल्कुल. The numerical value shows that the complex being formed, उसका आगे उसका formula लिख दो CONH3 4H2O taken twice. Is much more stable than the hexa-aqua copper complex. And once formed cannot be easily converted back to hexa-aqua copper complex. Is this clear?
Yes, sir.
पढ़ लिया सवाल ये वाला बच्चों? What is meant by the term stability constant? What did I tell you? What is it? It is the, भी बताया था मैंने. What is K star?
Equilibrium constant for when
For the formation of a complex. फॉर्मेशन
for the
लिख लो,
formation.
कॉम्प्लेक्स मॉलिक्यूल, कॉम्प्लेक्स आयन, कोई भी वर्ड यूज कर सकते हो. Is the equilibrium constant for the formation of a complex. समझा हमने लिगेंड एक्सचेंज से था, बट ऑब्वियसली इट शोज के पर्टिकुलर कॉम्प्लेक्स जो बनता है उसकी स्टेबिलिटी क्या है, जस्ट लाइक इन द प्रीवियस क्वेश्चन. Okay, now read this table thoroughly. They have given you few stability constants with a particular the metal is the same, but एक जगह जाके silver change हो रहा है, and with some corresponding ligands. What does the first part say after this? Use the data in the table to predict the formula of the complex formed in the greatest amount when a solution containing equal concentrations of both fluoride ion and SCN minus is added to iron 3 plus. Here's which one. We need to predict the formula of the complex that will be formed. दोनों आ गए. If the fluoride ligand is also present and the SCN minus ligand is also present, which ligand is more stable? The fluoride one. So which one will be formed? Fluoride. Fluoride कितने लगेंगे iron के साथ? You have to be careful with this.
Sir, last वाली value सबसे बड़ी है ना, 5 multiplied by 10 to the power 6.
You're right, bache, but right now we are comparing fluoride and SCN minus. These two ligands have been introduced to a particular solution which only contained iron 3 plus. तो लास्ट वाले में तो सिल्वर के साथ है, जी मरकरी के साथ, सॉरी, राइट. सो आयरन के साथ which particular ligand will bond and उसी की corresponding stability constant. So you only have to look at this and this. ये दोनों देखनी है. The first and the third one. कौन सी वाली ज्यादा stable है?
First one.
First one. Again, my question: how many
Question.
fluorides will be? Yes, बच्चे.
ये question incomplete है.
नहीं, second part आएगा ना, उसमें शायद इसकी value की जरूरत है. इस particular
नहीं,
part
I mean
नहीं.
जो आयरन वाला भी आपने मेंशन किया, ये सामने तो नहीं लिखा हुआ कहीं स्क्रीन पे.
दो आयरन वाले और से देखो. They have given you a general ligand exchange equation, बच्चे, that iron कोई भी metal हो सकता है M with any particular charge. When a ligand comes and it exchanges the water ligand and forms a particular complex and releases the water molecule, उसका stability constant they have given you like this. So generalized equation ऊपर लिखी हुई है. Is this clear?
Sir, I don't know why I don't get it.
Don't worry. Just have a look at this equation. Do you see this equation?
Yes.
When a particular metal is in this form of a complex and a ligand exchanges the water ligand and forms this particular complex with a particular charge and a water molecule. Now, what could the metal be? The metal could be iron 3, iron 3, iron 3, or mercury. And what could the ligand be? Fluoride, chloride, SCN minus, or Cl minus. Is this clear?
Yes, sir.
And with this particular metal and this particular ligand, this is the stability constant. With this particular metal and this particular ligand, this is the stability constant. Is this clear?
Yes, sir.
So that means in the first part, therefore, that iron existed like this, and we added both fluoride and SCN minus to iron containing solution. So two ligands were present then, F minus and SCN minus. दोनों में से which one will replace water, the one which can form more stable complex, and which one will that be? Fluoride. And how many fluoride will replace? Be very careful with this. One. Very good. The values that they have given you is just with one. So Fe, 5 water will remain. and one fluoride will attach. What will be the overall charge? +2. Reason पहले तो +3 था. Very good. Fluoride has a negative charge. उसके आने की वजह से overall a charge decreased. इसी का second part देखते हैं. उसमें we'll use that particular value. और से पहले सवाल पढ़ लो. A solution containing equal concentrations of both iron 3 plus and Hg2 plus is added to chloride. कौन सा वाला बनेगा? These two values, the second and the fourth one is what we need to see now. Yes, बच्चों. बताएगा मुझे आयरन भी था, सिल्वर भी था. It is added to a solution that already contained chloride ions. So two complexes could have formed: silver with chloride and iron with chloride. Which one? Sorry, my bad. बार-बार silver क्यों कह रहा हूँ मैं? It's mercury. Mercury with chloride and iron with chloride. Mercury will form. क्यों? क्योंकि उसका stability constant has a higher value. And which complex? Hg, H2O, 5 and Cl. And what will be the overall charge? +1. Is this clear? The next part भी देखते हैं. Yes, बच्चों. Case tab निकालना. How do we do that? Expression for case tab is all we need.
Sir, ये आपने how many ligands will replace और ये जो charge है वो कैसे determine किया?
Very good. तो देखो overall जो पहले हमें चीज given थी, the question gave you a general equation. It already had 6 water ligands and one of the water ligands is replaced और उसी के stability constants हैं. Is this clear?
Okay.
Mercury का तो +2 charge था. When a chloride ligand joined in, एक charge decrease again, we are left with +1 charge. Clear है?
Yes.
Yes बच्चों, इसमें क्या बनेगी? Anyone? Iron, Ed, taken twice, chloride, overall charge is -3, and long bracket for concentration in mole per dm cube, and iron, H2O 4 times, chloride twice, overall charge is +1. पर को नहीं इन्वॉल्व करते, Ed Yes, Bacho, can you tell me the units for this one now?
Mole -2, decimeter 4.
4, क्यों?
-6.
2.
Why
Yes,
-6? dm 6 हो जाएगा ना बेटे?
Yes.
dm 6. Is this clear?
Yes, sir.